Okay, number 5, we decided needed to be solved with the quadratic equation. One reason I decided that is that it cannot be factored if I try to factor. And my coefficient to x squared is not 1, and it's also not a perfect square to make a perfect square trinomial. So setting this equal to 0, now I'm going to solve using my quadratic equation. So I have x equals negative b plus or minus the square root b squared minus 4ac all over 2a. Hopefully we've learned to do what's inside my radical first. So we're going to go ahead and take care of that. So the square root of b squared, so 2 squared, minus 4 times a, so times 3, times c, so negative 12. So 4 times 3 is 12. 12 times negative 12 is negative 144. So if I want to take away negative 144, or subtract negative 144, remember that actually turns to addition. So really I have 4 plus 144. So I have the square root of 148. So I have negative b plus or minus the square root of 148 all over 2a. So I'm going to rewrite that over here. So now I have negative 2 is my b plus or minus the square root of 148 all over 2 times my a, so 2 times 3. And that we can go ahead and just make that 6. Okay, so there's some things that can be simplified here. Negative 2 over 6 can actually become negative 1 over 3. We can see that. But I also can simplify my square root of 148. So square root of 148, let's break that down. I know I can break it down to, well, I mean, very least I can break it down to 2 times 7, 4. And then we could break that down some more. So 2 times 37. So now I have a pair of 2s, so I'll take out a 2, square root of 37. So rewriting, I have negative 2 plus or minus 2 square root of 37 all over 6. Okay, and I'm not really sure, this one's a little complicated. I'm not really sure if I go ahead and divide this negative 2 and 6 and make it negative 1/3. I think I do. I think I need to have negative 1/3 plus or minus 2 square root of 37 all over 6. So this would be our final answer for this question. But that one's a little bit more complicated than what you will see most of the time. Okay, so problem solving with quadratic functions. During soccer practice, Alexis kicks a soccer ball whose height can be modeled by the function h of t equals negative 16t squared plus 24t, where h is the height of the soccer ball in feet after t seconds. How long was the ball in the air? So how long means I'm solving for the time. So I'm solving for t. So this is just me solving another quadratic equation. Okay, so let's look at negative 16t squared plus 24t and see how we want to solve this. So setting it equal to 0. First, I notice that I have a common factor between negative 16 and 24 of 8. And actually, let's make that a negative 8. So that becomes 2t squared minus 3t. I also know that I have a common factor of t, so I could actually take out a t. So now I can have negative 8t. So negative 8t is 2t minus 3. And now I'm actually almost done with solving. So I'm going to set both of these factors equal to 0. So negative 8t equals 0. And 2t minus 3 equals 0. And solving for t in both. So divide by negative 8. I get t equals 0. So this is my first x-intercept, and if you imagine them kicking the ball at the very beginning, at 0 seconds, my ball will begin on the ground. And now I'm looking for the next time, so this is 0 seconds. I'm looking for the next time my ball will be on the ground, so I'm going to add 3 to both sides. I have 2t equals 3. And I'm going to divide by 2, and I have t equals 3 halves, or 1.5. So the next time that my ball will be on the ground is at 1.5 or 1.5 seconds. So C. Now let's talk about some of these other ones and why they would not make sense. Actually, B could make sense and D could make sense just by looking at them and if I didn't know. But A does not make sense. I can't have negative seconds. So that would have been one that I eliminated immediately from my choices.